This is ARCAID, an advanced robot car for automated item delivery.
We created ARCAID to help people who need assistance. ARCAID can deliver small items to people. ARCAID software can be easily programmed to work seamlessly on any indoor layout. It can be used in hospitals, houses, and many other places.
ARCAID verbally alerts the recipient when the item has been delivered. It can work based on a predefined schedule. It additionally uses a line following method, enabling it to adapt to any indoor layout. It is a low-cost solution for navigation, and it works for extended periods of time. Additionally, ARCAID is capable of performing multiple deliveries on one layout.
The main components ARCAID uses include a camera, motors with encoders, and an advanced motor controller. ARCAID additionally consists of a Raspberry Pi 4, which is the brain of the entire robot and it processes the sensor data.
Now we will be demonstrating a live demo of ARCAID delivering items on a sample layout.
Welcome everyone. I am Jedi. I'm an autonomous delivery robot. I am on my way to my first destination. Waiting for the person to take the delivery items. I will wait here until the button is pressed or 5 seconds have elapsed. Finished all my deliveries and will return to my starting point. I have returned home and I am ready for the next delivery.
We'll now explain how ARCAID works. ARCAID uses an algorithm to follow the line. We first use SciPy's center of mass function to find out where the line is in the image. We then pass those values to a PID, which stands for Proportional Integral Derivative Controller. We also use encoders to make sure the robot runs smoothly on any surface. Because Python was too slow to count how many revolutions of the wheels, which we do using the encoders, we had to use C++, a faster language. We integrated them using Python extension libraries. Now I'll talk about the PID. For the PID, there's 3 terms, P, I, and D. We didn't use the I because our specific scenario didn't need it. So P stands for proportional. And pretty much the way we tuned it, we wanted when the robot only had a P, we wanted to be rotating and oscillating a lot. Then when we wanted to add the D, we wanted to make sure that it just smoothed out the oscillation. Now I'll pass it to Srijan to really explain how exactly we tweak these P and D terms.
So here is the example, or is the PID code that we utilized. And in this, you can see right here, we configure these variables for our PID to tune it. So we start with only a P term, and we slowly adjust it until we get heavy oscillation. Then we use a D to smoothen it out and make sure it goes straight. And I, we rarely use, but it might be useful while it's starting. And here, as you can see, we graph the data to analyze. After we log the data from the PID, we graph it to analyze it and further tune. And we zoom in over here to analyze the data, and we can see how the PID is interacting.
As you can see, the P, I, and D terms are graphed. If I could just zoom in to exactly show you how. So as you can see, we can see all of the terms here. This allows us to tune the PID in just the right way to make sure the P and D terms are the correct values. This will allow our robot to smoothly follow the line and follow it very fast.
To sum up, ARCAID follows the predefined path using a camera and uses a motor controller to control the motors with the PID output. It utilizes the Raspberry Pi 4, which is a microprocessor. ARCAID has been tested extensively on a vast variety of indoor layouts. ARCAID can be used on any in-house delivery path with no additional cost.
On behalf of ARCAID, I would like to thank you for watching this presentation. I am Kethan.
And I'm Trijo.